All right, everybody. Hope we're all having a good day. Unfortunately, I am not there with you today just because my daughter, she woke up with a sore throat. Notice the timestamp down here. It's 11:30 p.m. She woke up with a sore throat. Not really any other symptoms. She didn't have a fever or anything, so it's not like COVID related or anything. But she woke up with a sore throat, and so we're just kind of let her sleep in and stay home with her tomorrow. So hopefully she'll get better. Here's what I need you guys to do today. First thing I'm going to do is I'm going to go over the homework. Okay. I'm going to go through a couple of the problems at the end, or those couple of problems at the end, that 8 and 9, that could be kind of a doozy. So I will go over some of those questions. So make sure you get that out and then watch through the video key. Even if you didn't do the homework, which you should have anyway, you need to watch through this video because this stuff is pretty important. Some of it can get a little difficult. And then I'm going to go through section 6.5 day 2. Remember that I think I told you guys this yesterday, maybe not. There is no guided notes over section 6.5 day 2. Because that's not really, much new material, just a couple of more examples. Okay. So there's no guided notes. That is not a mistake that you don't have guided notes. So you do not have guided notes normally. You don't get guided notes in section 6.5 day 2. And then with the remaining time, you can work on the 6.5 homework. Okay. Now remember that tomorrow, I'm saying this as Thursday. Thursday is that weird day where everybody's kind of taking their tests. Some people are taking the AccuPlacer, some people are taking digital exams. So we're kind of treading water on that day. So tomorrow I will be able to answer questions on anything that we've learned in this video, and as well as going over these homework problems if we need to. Okay, so you see the key here. I'm going to kind of briefly go through some stuff here on numbers 2 to 9. Number 2 here, we pull out the 2x squared, leaves us this trinomial that's factorable, factors of negative 16 that add to get to, and actually I don't know why that says negative, that should say positive, that's weird. Factors of positive 16 that add to get to 8 are positive 4 and positive 4, so that's why you see an x equals negative 4 and an x equals 0. Remember, 2x, you have to set a GCF equal to 0 to get that x equals 0. It didn't ask me to, but I could state the multiplicity for these ones, since this is I see 2 here and 2 here. These are both a multiplicity of 2. Number 3, this is one of those ones where I would have introduced a new variable, made it like a squared minus 37a plus 36, and then you've got an a minus 36 and a minus 1, reintroduce x squared. You get 2 difference of squares, and you see them here. So plus or minus 6 and plus or minus 1 are my solutions. Here's numbers 4 and 5. Add the 48x to the 5th over to the other side and remove the 4x to the 5th. You're left with this trinomial, which reduces down pretty easily. Roots are 0, coming from here, positive 3, and positive 4. The next one here, subtract the 4x squared over the other side. Remove that x squared. Make sure that you remember how to factor that. I'll just go through that real quick. When you've got a value up front, you want to take first times last to get negative 12. Factors of negative 12 to add to get the positive 11 are negative 1 times 12. So that means that would be a 3x squared minus 1x plus 12x minus 4. And then we factor by grouping. We remove an x to leave a 3x minus 1. We remove a 4 to leave a 3x minus 1. So that means we've got, and that's why you see the x plus 4 and the 3x minus 1 here. I set this one equal to 0, I get the positive 1/3. I set this one equal to 0, I get this negative 4. And remember, the x squared setting equal to 0 is x equals 0. So the roots are 0, 1/3, and negative 4. Here's 6 and 7. You notice I purposely don't have 8 and 9 done yet down here. I would subtract everything over to the left side, remove my 2, and then it does factor by grouping. So I can actually remove the x minus 6. And then don't forget that this is a difference of squares. That's x minus 4, x plus 4. So my solutions are 6, negative 4, positive 4. This does not create any sort of solution out there. There is not a 0 as a solution. 0 is only ever a solution when you pull out an x as a GCF. Taking a look at number 7 here, this is another one of those ones where I would have said, okay, this is a squared minus 29a plus 100, and then factored it down to say, okay, that's 25 and 4, so a minus 4 a minus 25, and then plug the x squared back into the a. But I get plus or minus 2 and plus or minus 5. Okay, so here are the beasts, numbers 8 and 9. Okay, I'm going to do 8, show it all the way through, erase it, and then do number 9, show it all the way through, then erase it. Okay, so my first line of defense here is to try to factor this down at all. Well, factor by GCF, that I can pull out a 2x. So we're left with an x to the 4th plus 6x to the 3rd plus 8x squared minus 6x minus 9 equaling 0, right? Just divide everything by 2 and remove one of the x's. So I get an x to the 4th, 6x to the 3rd, 8, negative 6, negative 9, and remove one of the x's. 5, 4, 3, 2, 1, so it's 4, 3, 2, 1, 0. All right, now, this does not factor. So remember, when it doesn't factor, the only thing left to do is go to the calculator and plug it in. X to the 4th plus, oops, I've got to go into my y equals, duh. I've got x to the 4th plus 6x to the 3rd plus 8x squared minus 6x minus 9. I'm just going to double check it. X to the 4th plus 6x to the 3rd plus 8x squared minus 6x minus 9. Okay, I'm going to graph this. Okay, so what do I see here in this graph? Well, I'll put it over here for right now. I see a couple things, and again, this is all still number 8. Don't get confused. Then this is number 9. I see this point that looks like a 0. I see this point that looks like a 0, and I see this point that looks like a 0. So remember that whenever it bounces off like that, that's an even root. And these are both single roots. Okay, when it goes straight through like that, those are single roots, meaning there's only one there. Okay, so where does this look like these happen? This looks like it happens at, let me move this little circle that I drew there. Yeah, it looks like, ooh, yikes, what the heck happened? Let's put that back, whatever. This looks like it's at 1, at -1, and then 2, -3, right? Now, those are all viable options for me to try to synthetically divide. I know I can pull at least 2 of them out of here. I can pull one of them from here and then one of them from here because they're going straight through at these points. And I know this is at least a 2. It could be a 4, it could be a 6, but I know it's at least a 2. So let's start by, I don't know, 1's an easy number to put in. Let's take that 1 and synthetically divide out. 1, 6, 8, -6, -9. All right, so we pulled out a 1, a 7, a 7, a 15, a 15, a 9, a 9, a 0. All right, so remember, don't forget the 2x that we brought out at the beginning. This x equals 1 corresponds to an x minus 1. And then we've got x to the 3rd plus 7x squared plus 15x plus 9. Okay, this still does not factor, so I keep going back to this list. Okay, I've exhausted this one. Now let's try this one. I don't know. Or I could pick -3, it looks like. So let's try -1. And again, we keep chipping away at the piece that's not factored yet. 1, a 7, a 15, a 9. So we get a 1, a -1, a 6, a -6, a 9, a -9, a 0. So this means that I've got a 2x that was originally out front, the x minus 1 coming from above, the x plus 1 that we just removed, and then x squared plus 6x plus 9. All right, so now that factors. I get an x minus 1, x plus 1, x plus 3, x plus 3. Okay, so finding all of the solutions there, this would give me an x equals 0. This would give me an x equals 1. This would give me an x equals -1, so let's say plus or minus 1. And then these both would give me an x equals -3. Okay, so these are all single roots with a multiplicity of 1 because they only exist one time, right? And then, but this guy happens twice. So we say this with a multiplicity of 2. Okay, and that's my answer done it. All right, if you need to write any of that down, please pause and do so. I'm going to erase it now. Okay. Oh, yikes. I didn't do a very good job of erasing. There we go. That's much better. Okay, let's get out of it. Let's do number 9 now. Okay, so I would first try to factor anything down. Looks like doesn't factor. Can't even pull anything out. Okay, so that means I got to go to my calculator and I plug this in. I say x to the 6th minus 12x to the 4th plus 48x squared minus 64. I'm just going to double check my numbers here. X to the 6th minus 12x to the 4th plus 48x squared minus 64. Let's graph that. Okay, now I hope you watched the animation there. I'm going to actually just do this again so you can see it because it may look deceiving. Look, watch here. Did you see how it kind of slowed down in there? That's a key indicator that bent through instead of just passing straight through. Okay, so I see 2 zeros going on, one here and one here. And because they bent through, I know that this is an odd, these are both odd multiplicities. I don't know how odd they are, but I know that they are odd multiplicities. This one looks like it's a 2, this one looks like it's a -2. Now, and they're odd multiplicities, at least 3. It's got to be greater than or equal to 3. It can't be 1, right? It can't be 1, or else it would have gone straight through. So I know that I can use these at least 3 times each. So I've got a lot of possibilities that I could use to synthetically divide. Let's start with positive 2. I can choose -2 if I'd really like to, but let's choose positive 2. 1, there's no x to the 5th term. Here's the x to the 4th term. There's no x to the 3rd term. Here's the x squared term. There is no x term, and then the -64 at the end. Okay, that gives me a 1, a 2, a 2, a 4, a -8, a -16, a -16, a -32, a +16, a 32, a 32, and a 64 to get a 0. Okay, so this corresponds to an x minus 2. And then we've got x to the 5th plus 2x to the 4th minus 8x to the 3rd minus 16x plus 16, squared plus 16x plus 32. All right, well, I've knocked down one of these. I've got 3, now I can knock it down to 2. I can jump ship and go to -2 if I'd really like to. But let's keep pulling out a 2. Let's keep chipping away with these 2s because I know I can use it at least 3 times. So let's try to use it 3 times and see what happens. I've got a 1, a 2, a -8, a -16, a 16, and a 32. I'm using it positive because it's easier to multiply. 1, 2, 4, 8, 0, 0, -16, -32, -16, -32, 0. Okay, so that means I've already got 1x minus 2 pulled out from the up top. This corresponds to this x minus 2 right here. And then I've got an x to the 4th plus 4x to the 3rd plus 0x squared minus 16x minus 16. Okay, keep chipping away. Let's use 2 one more time. 1, 4, 0, -16, 16, or -16. 1, 2, 6, 12, 12, 24, 8, 16. Okay. So now this leaves me with an x minus 2 from the first one, an x minus 2 from the second one, an x minus 2 from the last one that we just did, and we're left with an x squared, x to the 3rd plus 6x squared plus 12x plus 8. And now at this point, I now have to jump ship. I've used it 3 times. I cannot be sure that it happens 5 times. I know it's at least 3, but I can't tell if it's anything beyond 3. But there is the -2 out here that I have not touched. So let's run through a -2 and see what happens. I've got a 1, a 6, a 12, and an 8. All right, so 1, -2, 4, -8, 4, a -8, and 0. Okay, good. So now I've got these 3 x minus 2's sitting out there. And then I've got an x squared plus 4. Oops, I forgot my, excuse me. I forgot this one. This is an x plus 2. And now I've got the leftovers, x squared plus 4x plus 4. And that, my friends, is factorable. Factors of 4 that add to get to 4, 2, and 2. So you've got this factors into x plus 2. Forgive me for not writing this whole thing out again. Right, so it kind of drops down there, right? All right, so now that means I've got an x equals 2 and an x equals -2, both with a multiplicity of 3. All right, well, that was fun. It was fun on a 11:48 on a Tuesday night. Okay, so no guided notes again today. We're just going to do a couple more examples. The first one is called, I like to call it the volume of the box problem. So do this one along with me, please. The design of a box specifies that its length is 4 inches greater than its width. The height is 1 inch less than its width. The volume of the box is 12 cubic inches. What's the width of the box? Okay, well, I know volume is equal to length times width times height, right? But I've given some restrictions on all of these things. I need to figure out what my length, width, and height actually are. But notice that my length is dependent on my width, and the height is dependent on my width. Okay, so if I make my width x, my length, therefore, is 4 inches greater than its width. So 4 plus x. Let's say that that's x plus 4. Seems weird to write 4 plus x. And the height is 1 inch less than its width, x minus 1. And I know the volume is 12, so here's the equation that I can write. 12 is equal to x plus 4 times x minus 1, length times width times height. All right, so let's multiply these things out on the right side, because to find the solutions, I really have to get it set equal to 0. So let's distribute this in, x squared plus 4x. And now let's multiply that with the x minus 1. So 12 is equal to x to the third minus x squared, distributing the 4x. 4x squared minus 4x. All right, combine like terms. 12 is equal to x to the third plus 3x squared minus 4x. And I subtract the 12 over to the other side, so 0 is equal to x to the third plus 3x squared minus 4x minus 12. All right, I can factor that. Let's factor by grouping. Pull out an x squared, we're leaving an x plus 3. Pull out a -4, we leave an x plus 3. All right, so I get an x plus 3, and then an x squared minus 4. So that means I factor down the x squared minus 4. That gives me an x plus 3, x minus 2, x plus 2. Now, what are all my solutions here? Well, my solutions are x equals -3, x equals +2, and x equals -2. So those are solutions for my graph from my equation. Well, obviously, I can't have negative lengths. So these 2 options get thrown out the window. The only viable option that we have is x equals 2. So that means it says to find the width, but I can find all dimensions. So that would be a 6, this would be a 2, this would be a 1, a 6 by 2 by 1 box. Okay, well, that was fun. The last thing that I want to talk about is this thing, what we were doing here with all of these example problems is that, or especially the homework problems from the night before, we were just factoring it down so that we could possibly get all of the roots. Now, what happens when the roots are irrational? What happens when this doesn't cross nicely, like say this 2 and -2? What happens when it's not factorable? Well, when it's not factorable, it may have irrational roots. And we have this irrational root theorem. This honestly isn't something that I would necessarily need you to write down. It basically just says we're going to have something that's called a rational, R-A-T, rational root theorem. That is going to be a lot more useful than this irrational root theorem. It basically says that whenever you have an irrational root, the conjugate must also be a root as well. And I mean, I don't know how much that helps us. It's saying that, like, okay, if I know 1 plus radical 2 is a root, I know 1 minus radical 2 is a root. That'll help us a little bit more later on, but not really for our purposes right now. But what are the implications? We'll take a look at something like this. Now, obviously, this does not factor. I shouldn't say obviously. That might be hard to see that it doesn't factor by grouping. If I group these first two terms, I can pull out an x squared, leaving an x plus 5, but there's no way that's going to be an x plus 5. So I've got to use my graphing calculator. So I go to my graphing calculator because that's the next step, right? We exhaust our possibilities with the flow chart that's actually probably still on the board. And now we plug in x to the third plus 5x squared minus 3x minus 3. And I graph. Oh, what did I do? Go to. Oh, I didn't do the to the third. Oops. X to the third plus 5x squared minus 3x minus 3. Okay, graph that. Okay, so it looks like it went straight through. And let me make this a little bigger. It looks like it went straight through, straight through, straight through. Okay. Now these look like they're not at good points. These two zeros look like they're not at good points, but this one looks good. That one looks like it's at an x equals 1. So let's test and see if that's actually at 1. So that's a 1, a 5, a -3, and a -3. So my solutions here are 1, a 1, a 6, 6, a 3, a 3, a 0. All right, so that means I've got x minus 1, x squared plus 6x plus 3. And then we can see here that this is going to be irrational. Okay. The fact that that's going to be irrational means that I'm going to have to use some other method of reducing it down other than factoring. What can I do? Well, I can use the quadratic formula. I can complete the square. I can do whatever I want. Okay. Let's complete the square. Why not? Sounds like fun. 11:55 on a Tuesday night. So I've got x squared plus 6x plus 3 equals 0. Right? Because now at this point we can set them both equal to 0, right? That zero product property isn't just like for binomials. Once it's factored down, once it's fully factored down, I can set each piece equal to 0. So now I've just got to basically solve the quadratic, which we know how to do. We've done it many, many, many times over. Complete the square, quadratic formula, whatever. All right, well, complete the square. X squared plus 6x. Subtract the 3 over to the other side. Fill in my blank of a 9. Right? How do I get that? 6 divided by 2 is 3. 3 squared is 9. So I add 9 to both sides. All right, that gives me an x plus 3 squared on the left side, and then a 6 on the right side. I square root the opposite side. I get x plus 3 is equal to plus or minus radical 6. And then I subtract the 3 over to the other side. X is equal to -3 plus or minus radical 6. And that, my friends, are the two other locations. I see the location of 1 over here, but I didn't know what these were. But you know what they are? The solutions down here. One is -3 minus radical 6. That one is the -3 minus radical 6. This one is the -3 plus radical 6. All right, let's take a look at this one more time. I'd like you guys to try to do this one on your own. Go ahead and pause and see if you can figure it out, and then play when ready. All right, this doesn't factor, not even by GCF, so let's go in and graph this. Got my y equals here. I've got 2x to the third, 2x to the third, minus 9x squared, plus 2. Ooh, yikes. Does it cross anywhere nicely? Ooh, geez. That's not good. What to do? What to do? Hey guys, if it doesn't cross nicely right here, I guess I could try to see, like kind of just pick, like maybe this is at 1/2. Like maybe this is what I should do. Let's see if that's at 1/2. So that means I've got a 2, a -9, a 0, and a 2. I wonder if that's actually a 1/2. Maybe this is like a -1/2. I got a 2, a 1, a -8, a -4. Yeah, this is right. This is right. Look at that. So I've got an x equals 1/2. I'm not even going to write the factored form out. And then this is a 2x squared minus 8x minus 4 equaling 0. So remove the factor of 2. That's going to give me an x squared minus 4x minus 2. Now that is not factorable. So what I have to do there is complete the square or quadratic formula. We completed the square last time, so let's quadratic formula. The opposite of b plus or minus the square root of b squared minus 4ac, all divided by 2a. Okay, so that means I've got 4 plus or minus the square root of, that's 16 plus 8, so 24. It's late. I better check that. -8 times -2 is +8. Or sorry, -4 times -2 is +8, plus 16 is 24. Okay, I'm good. And then we got 4 plus or minus, reduce that 24, that's 4 times 6. 6 times 4 is 24. So 2 radical 6 all over 2. And then I break this apart. I divide each piece by 2 here. This is 2 plus or minus radical 6. So my solutions are x is equal to 1/2 and x is equal to 2 plus or minus radical 6. This is probably 2 plus radical 6. This is probably 2 minus radical 6. Okay. That was kind of a tricky one because you had to do that. You kind of had to guess at the fact that it was going to be a 1/2, but yeah, not too bad. All right. Again, I hope we're having a good day, and I'll see you guys later.